Chemistry lessons, naming covalent bonds. Now remember, covalent bonds are between two non-metals, and our non-metals, you get a blue pin up here, our non-metals are the ones that are listed in green and yellow here, and let's not forget about hydrogen, okay? Because remember, hydrogen and helium sit up here along the top in row 1, but we could move those in many different places. If we had this chart by its electronegativity, hydrogen would sit right about in here, okay? But what we're talking about now is between non-metals, and these are the only guys over here we have to worry about. Now, covalent bonded molecule, like we just talked about here a little bit ago, if you just watched the, covalent bonding video, covalent bond is it's going to have more of an equal distribution of the electron around both of the nucleuses, or all three of the nucleuses of the elements that are involved, where an ionic bond is going to have more, they call it a transfer, but it's not really a transfer. It's just that this electron here is going to spend more time over on this side. It's still going to go over onto the other element a little bit, just spends more time in this area here. Whereas a covalent bonded molecule is going to be spending a lot of time around even both of the elements type deal. So they call that sharing, and they call the other one transfer. Basically, as we talked about earlier, it is just a difference in the electronegativity of rating that we have. So we'll squeeze this back down here. Now let's look at a combination of carbon and oxygen. Okay, I could either just have one carbon and one oxygen. I could have two oxygens with this carbon, or as we've already seen, one of the polyatomic ions that we have carbonate, which has three carbons. So we have the ability, I can't call this carbon oxide or carbon, because they're all carbon and oxygen. So the naming rules we use for ionic bonding, we cannot use here. We have to have a different naming system when we name things. If we take a look at carbon and hydrogen, okay, carbon and hydrogen could look like this. It could look like this. It could look like, two of these things. It could look like here. Okay, same thing. All of these are different, carbons. This one here could be, if this was CH4, we'll put a 4 here. This could be methane. Okay, and two of them here. And let's see, 1, 2, 3, 1, 2, 3. That'd be a 6. Okay, get back into my organic naming. If I got two carbons here, we would call that ethane. Okay, 3 carbons is called propane. Okay, so there's specific naming rules. Then this is in organic, which you don't have to memorize. But as you can see, I can take a carbon and a hydrogen, and I can have different combinations of it. So once again, I need a new naming system, or these compounds. What we use on covalently bonded molecules is the Greek naming system, and this is something you're going to have to memorize. You need to memorize these right here as they relate to the number: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. These are how we're going to name this. So what we're going to do is, we're going to use one of these prefixes depending on how many of those non-metals are bonded together. Okay, one of them right easily. Okay, you heard of carbon monoxide, 1 oxygen. You've heard of carbon dioxide, okay, 2 oxygens. So this is how we name these different elements. We use this Greek naming system, and you're going to have to memorize this. I cannot stress that strongly enough, okay? Memorize, because this is a big part of the mandatory pass exam. Now, practice. Let's say that you have P5O10. I'll give you a couple minutes now. Name that. Alright, here's the name of that. You've got penta, phosphorus. And then, as always, just like in the other one, we would change the ending of this to be IDD. So this would be penta, and then 10 is deca, deca oxide. Okay, so we have to list the amount that's there. And the first one we leave its name, list the amount that's there, and then change the ending of the last one to IDE. Now here's a tough one. I want you to name this in the actual covalent bonding, okay, naming system. Give you a second here. And if you wrote this, dihydrogen monoxide. Yes, that is the correct name for water that we call water. It would be called dihydrogen monoxide, okay? And this one you already know, you've already been listing this, okay? You could call it monocarbon if you want, but since there's only one, we usually don't use the mono at the start, but it wouldn't be wrong. So if you have to learn it that way, go ahead. All right, but this would be carbon. How many oxygens are there? 2 dioxide. So in covalent bonding, all you need to remember is that we have to list the number of the element that's there. Okay, we use the Greek numbering system, mono, di, tri, okay, tetra, penta, hexa, hepta, octa, nona, deca. Go back and review those as many times as you can so you could get those down into memorization, because it is a big part of the mandatory pass exam. Remember, chemistry, never give up. Come in and ask all types of questions and stay gritty out there.